Welcome back. Right now, we are going to take a deeper look at solving inequalities. And earlier in our earlier video, we showed you how to solve a simple inequality. Now we're going to look at a two-step inequality. And again, we're just going to follow the same rules that we follow when we're solving an equation. So the first thing I need to do is to build my wall. And when I build my wall, I am doing nothing more than just separating my problem into a left side and a right side. Then I want to follow and make sure that my terms are combined as needed. And on the left side, we are combined. The negative 25 cannot combine with the negative 4x because the negative 4x has a variable. On the right-hand side, there's nothing to combine. I also want to make sure that my variable terms are only on one side of my equation. Sometimes we have them on both sides, and we have to use some inverse operations to maneuver those around. So now I'm ready to follow SADMAP. Now, if you remember, SADMAP starts with subtraction and addition. Then we look at division, multiplication. Then are there any exponents or are there any parentheses, also known as grouping symbols? So the first thing I want to look at is there anything being subtracted or added to my variable term? Now my variable term is actually this term right here, the negative 4x. That's my variable term. So when I circle that, what I see is I have this negative 25 out here. So this negative 25 is technically being subtracted. So I'm going to use an inverse operation, and I want to use my identity property. So I'm going to add 25 because a negative 25 plus 25 has a property of 0. And my fundamental rule of algebra is whatever I do to one side, I must do to the other. So I'm going to add 25 on the right-hand side as well. Now, when I do this, we just said that these are going to end up equaling 0. And 0 minus 4x is just negative 4x. And 3 plus 25 is going to be 28. Now, this inequality symbol is going to drop straight down because I haven't done anything to cause it to change. Remember, the only time that this is going to change is if I multiply or divide by a negative number. So, double checking, subtraction or addition to my variable term has been completed. So next we move on to division or multiplication. So my variable is x, and I have a negative 4 being multiplied by my x. So what I want to do is I want to use my identity property, and I need this to equal 1. So a negative 4 being multiplied, I'm going to divide by negative 4. And again, what I do to one side, I must do to the other. So negative 4 divided by negative 4 is 1, and 1 times x is x. 28 divided by negative 4, again, a positive divided by a negative is going to be negative. 28 divided by 4 is 7. Now, if you remember earlier, we just mentioned that when we divide by a negative number, this symbol is going to have to change directions, right? Because that negative sign causes us to flip to the other side of our number line. So we come up with a solution set of x is less than or equal to negative 7. Now again, we're going to take some time here. Let's graph this. So I want to graph my solution set. And what I'm going to look at is where's my 0? So my 0 is going to be right here. We have negative 1, 2, negative 3, negative 4, and here is negative 5, negative 6, negative 7, negative 8, negative 9, and here is negative 10. So I'm looking at all of the terms that are less than or equal to negative 7. So I'm going to go to the negative 7, and because we can be equal to it, I don't want to use an open dot. I want to use a closed dot because we can be equal to that negative 7. And I'm looking at all the terms that are less than that. So the less direction is to the left. So there is my solution set of x is less than or equal to negative 7. So next, we want to try a different problem. And this problem is similar in the sense that it's a two-step inequality. But however, you'll notice that now we have some division. So I'm going to start off the same way that I start off any problem. I'm going to build my wall, divide it to a left and right side, make sure my terms are combined, And they are. My variable is only on one side. So again, we're going to follow SADMAP. SADMAP tells me to take care of the subtraction addition. So I have 6 being added to my variable term. So we're going to subtract 6 on both sides. Again, I'm trying to reduce these numbers over here. So we want to use the identity property. So plus 6 and a minus 6 is a 0, which keeps the identity for the x divided by negative 5. And 32 minus 6 is just going to be 26. Now again, this inequality symbol is going to come straight down as less than or equal because we haven't done any multiplication or division by a negative number. Now, this is where some students have trouble. This is not to be considered as a fraction. It is a fraction technically. However, we want to look at it as a division problem. So x is being divided by negative 5. Now, to use the identity property, we want to get this negative 5 out of here. So what we're going to do is we're actually going to multiply both sides by negative 5. And in doing so, what is going to happen is negative 5, all right, is going to cause a 1 to develop here because we have a negative 5 technically over 1, right, being multiplied, and these are going to cross simplify to 1s. All right, so we're just going to be left with x over on the left-hand side. And on the right-hand side, we have a positive times a negative, which we have said is going to be negative. And then we have 26 times 5. So to show my work here, 26 times 5, we multiply this, and 5 times 6 is 30. Let's write our 0 and carry our 3. 5 times 2 is 10, plus 3 is 13, so it's negative 130. Now, remember, when we divide by a negative, or in this case, when we multiply by a negative, the symbol has to change its direction. So now we have x is greater than or equal to negative 130. And again, if we want to graph this solution set, I'm not going to draw all 130 dashes, but let's just put negative 130 right here in the middle. And over here would be negative 129. And over in this direction would be negative 131. And we want all the numbers that are going to be greater than or equal. So again, equal means closed dot. So we have greater than or equal, and greater is to the right. So my solution set would look like that. And we'd have an arrow pointed to the right direction. So again, hopefully this helps you gain some perspective on how to solve our inequalities. The big reminder is solve it like an equation. The only time we're going to have a little change here is when we actually go through and divide by a negative or multiply by a negative, our sign changes direction.